this video, we're going to look at function notation. Our learning goal for the video is to solve questions involving function notation, and I guess also to understand function notation, although function notation itself is not that difficult, which we've already talked a little bit and put some of functions into this notation, so we'll just go into it more. In the last video, we saw that a line was in function notation. So if an equation is a function, it will often have a function name. We're just renaming it. It will be written in quote-unquote function notation. So we looked at a line. Here is our line, y equals 2x minus 1. All that we need to do to put this into function notation is to replace the y with an f of x. Now we read this as f of x or f at x, which means that this function is named f and it depends upon the variable x. So we'll see a couple questions coming up where it will use the function notation. Now we've been writing some functions, or we've seen functions with this f of x, but we haven't had to deal much with anything subbed in for the x. So that's going to come up in this next slide here. So in an example here, we've got f of x equals 3x plus 5. This is a line. Here the 3 would be our slope, the 5 would be our y-intercept, and now it's saying find f of 4. So all this means is that we're going to find y when x is 4. So instead of x now here, like there was in the equation, it's got a 4. So what it's saying is let's sub in 4 for x. So f of 4 is equal to 3, and we're going to sub in our 4 there for x, plus 5, and now we've just got to start solving this stuff. So 3 times 4 gives us 12, plus 5 is still there, and 12 plus 5, we get 17. So f of 4, and I should write this f of 4 down here the whole way. Just this pen isn't as neat as I would like it to be. F of 4 equals 17. So, and it's as simple as that. There are a few trickier ones that'll happen. So for example, in this one, we are given a quadratic. I know that it's quadratic because the highest degree is 2. And this one's called g of x. So this function is now denoted with a g. It could be anything if we're dealing with, I think in the last unit we were doing some revenue questions and profit questions, and we had r of x and p of x. So all it's saying here is we want to sub in -2 for x. So g of -2 is equal to 2 times -2 squared. Wherever there is an x, I'm going to put in -2. So 3 times x is now 3 times -2 plus 1. So if we follow BEDMAS, 2 squared is a positive 4. 3, -3 times -2 is a positive 6. Plus 1. 2 times 4 gives me 8. Plus 6 plus 1. I add this all up. 8 plus 6 plus 1. I end up with 15. And so we've got g of minus 2 is equal to 15. Okay, now I may need a little bit of extra room, so let me just kind of switch to the next one to do this next one here. Okay, so we'll ignore this. We just finished that one. But now we've got g of 4, so we need to sub in 4 into our g of x function, and then subtract g of 2. So I'm going to start this over here. G of 4 minus g of 2 is equal to, now g of 4 is going to be 2 times 4 squared minus 3 times 4 plus 1. That's g of 4. But now I have to minus g of 2. So g of 2 is 2 subbed in for all the x's. Minus 3 times 2 plus 1. And I'm putting these big brackets here to show that this is the second one over here. Here's the first one. We could put this one in big brackets too if we wanted to. This one over here is my g of 4 minus my g of 2. Now I can start solving all this stuff. 4 times 4 is, we're going to have 16 here. Minus 3 times 4, we're going to have a minus 12. Plus 1. We're going to subtract over in this one. 2 squared is 4. Minus 6 plus 1. Okay. Continuing with Bedmas here, we've got 2 times 16, so 32 minus 12 plus 1 minus 2 times 4 is 8 minus 6 plus 1. And over in this bracket, if I put all this together, I've got 32 minus 12 plus 1, we've got 21 minus 8 minus 6 plus 1 is 3. So in the end, these big brackets, we can get rid of them if we want to. It'll just be 21 minus 3 here. 21 minus 3, we've got 18. So we know that g of 4 minus g of 2 is 18. Okay, so we just subbed in to each of the, well, to this equation up here twice. We know that g of x is this. We subbed into this twice with a different value that it asked us for and subtracted the 2. The one other thing that we might get on this early one is find x if g of x is 21. So now g of x over here is equal to this function. But now it's saying not subbing in for x. This is like thinking of setting y equal to 21. So we're going to sub in this 21 over here for g of x. So we are going to have 21 equals 2x squared minus 3x plus 1. Now, whenever I have a quadratic like this, we want to set it equal to 0. So if I minus 21 from this side and minus 21 from this side, I will have 0 over here, and this will be 2x squared minus 3x minus 20. Now, what's unfortunate about this is there's a number in front of my x squared term. So this is a complex trinomial. So if I were to factor this, I'm going to look to factor first. If you can't factor, remember we're going to use the quadratic formula. But I'm going to look and see if this factors. I think it might. So 2 times 20 is minus 40. So I'm looking for two numbers that give me minus 40 and add to give me minus 3. So remember, they multiply to give you AC and add to give you B. So two numbers that multiply to give me 40 are 8 and 5. They're off by 3. If I make the 8 negative and the 5 positive, that will add to negative 3 and multiply to 40, negative 40. So I'm going to sub these two in for the middle term here. You can sub them in any order that you want. I just picked the order that I wrote them down. You're going to group the first two in common factor and group the second two in common factor. So out of the first two, I can take out a 2x, and I'm left with x minus 4. And out of the second two, I can take out a plus 5, and I am left with x minus 4, which is good because we want to get the same bracket here. Then we write that bracket out front, x minus 4, and the leftover bits from our common factoring in the other bracket. And now we can easily see what makes this equal to 0. Well, if x were 4, 4 minus 4 would be 0. And over here, if x were minus 5 over 2, x would also be equal to 0. So these are the two solutions that would give me g of x equaling 21. So if I were to sub in 4 into this equation, we would get 21. If I were to sub in minus 5 over 2 in for x into this function, then I would get 21.